Добрый день.
Good afternoon, dear colleagues. I'd like to welcome all of you at AIJ in our session on recommender systems. My name is Ivan Kuzmin, and I'm the Recommendation Solutions Director in Sber ecosystem. Ivan Kuzmin, Senior Management Director for Technological Development of the Recommender platform Sber. We're talking about movies, restaurants, social media. In all of this, we are relying on the algorithms. And today, our wonderful speaker panel is going to give you an idea how this system is built. And also the recommender system. You can ask your Q&A, your questions of the speakers using the QR code you see on the screen now. Our first speaker, Dmitry Bugaychenko, the head of data scientist team at Sber, who is going to tell you about how to bring the bandits into the bank. Dima, you're muted. Good afternoon, dear colleagues. Thank you very much for your kind introduction. Today we have a very interesting subject on the agenda. I think this was one of a few bank meetings that was attended by practically everyone. We never had to move it because the subject of the meeting was called "How to Bring Bandits into the Bank." Everyone were intrigued, and it was a resounding success. So today I will endeavor to share some of the experience of the trial. Now, let me introduce myself. I have long been into development of various IT solutions, and the last 10 years of my life were dedicated to development of recommender system of various types. This is the cloud, music, news, social media. And I have been with Sber retail business block developing the recommender system inside Sber retail business. This subject is very close to my heart, dear friends. First of all, because RecSys is a great case in point of technologies, mathematics and business conjoining into single synergy. So to build a recommender system, we need to use modern machine learning algorithms of various types, because the RecSys needs to analyze the content, range the offers, analyze user behavior. And also today we're seeing new recommender systems that are not only selecting the content for the users, but also generate it independently. And certainly for all of this to function, many technological tasks need to be resolved, since users in a large project would like to see fast recommendations, fresh recommendations, and this places high requirements on data reliability and system efficiency. For these cases of RecSys systems to be successful, we need to select the correct application point for the business and formulate the goals, the KPIs. This is the point of synergy for all of the three modern project frameworks. Now, recommendations at Sberbank Online. You can may be excused for thinking that RecSys and banks are far apart. However, this is not the case. Sber, with its huge retail network covering the whole country, uses it. And you may test it for yourself in our mobile app called Sberbank Online. As soon as you open the app, you will see on the front page, you will see many blocks that are selected using the RecSys algorithms. These are the blocks with frequent operations and many other types of educational and news content introducing you to bank services and using them. This is also various personal offers from the bank. And if we go a step deeper, Sberbank Online has a whole ecosystem catalog with recommendation catalog that lists many ecosystem services and content from our ecosystem partners. Apart from Sberbank Online website, we're also using many other channels. For instance, right now we're running a wonderful promotion called a Green Day. And at Sber and Sberbank Online, you may see personalized offers, more examples of recommendations at Sber, and separately we're conducting work with proactive recommendations and push notifications that are generating huge user activity, but as a different to other approaches, can also lead to negative effects if we overpush the user. So, if we look at the general picture, most of the tasks that use REC systems at Sberbank are distinguished by special characteristics. First of all, the set of our off-product offers for customers is somewhat limited and is numbered in 100 or maybe a few hundred offers, except for few landings and ecosystems where we're working with large catalogs. Accordingly, inside Sber, all of the product offerings and all of the creative work is strictly controlled. And Sber in this is drastically different to social media that uses user-generated content, and authors of this user-generating content pursue their own goals. So here we have a large number of teams that have their own KPIs for development of own product lines, and that really need to quickly confirm various hypotheses, look at product, measure product changes, measure customer feedback, and select best performing models. Another specific bank feature is that we have accumulated quite a lot of user data, thereby enabling the construction of comprehensive user profiles with an understanding what may be attractive for these users. So we're in a situation with small catalog with no risky clickbait offers. However, this catalog is constantly evolving, and the teams would always like to test their hypotheses, testing new projects. So if we look at this case, we immediately see that this is greatly that this would be great to use the multi-armed bandit. The mechanics is the following. You need to understand the alternatives for actions, and you need to identify which hand action for the multi-armed bandit produces more benefit. In this vector, we need to first collect the data, learn the order, the sequence, and only then, after processing, we can begin to use it. Now, since we're working in a REC-sys dynamic environment, because the reaction of customers to users to same offers may be drastically different, we need to also constantly remember to update our data, thereby providing a timely description of user feedback. This is also addressed in many of the approaches to the multi-armed bandit. We tried using this, and one of the approaches is using hybrid contextual multi-armed bandits that are compared to traditional models. They go through the information in user profile using own knowledge and thereby generate user feedback scenario predictions. Now, what is necessary for the case to be realized and to bring the bandits into the bank? Speaking of the classic bandits without accounting for user properties, it's quite straightforward. What we do is generate certain recommendations with initial bandit settings, send it to the users, users provide feedback, and based on this feedback, the model is updated. Without context, the model is quite simple. In most cases, any data on updated model is also sent back to inference. Now, speaking of non-contextual bandits, the actual models contain just a few numbers, so they don't present any problems with memory, storage, or processing. But as soon as we add context, I mean user information, everything changes. Input data is enriched, the models become heavier and require new elements. So accordingly, we need a mechanism that would allow us to send user properties, get it to the RecSys model to build recommendations, and same with the model. When the ratios are updated, we need to send it to the inference perimeter. So importantly, bandit approach, similar to any other ML approach, is quite sensitive to the speed of model updates. Both recommendations are usually structured at the search query time, and the model update takes a very short delay in terms of receiving feedback, because the longer the model processes the query, the longer is the phase when it is learning, amassing data, and accordingly more losses due to ineffective traffic will occur. Now, having developed the conceptual architecture, we have moved on to implementing the first case. The first case was quite unplanned, actually. Initially, more precisely, it was planned in a completely different format. But then, with the COVID-19 pandemic, everyone went to homework, and Sber needed to support its huge audience. So we have developed a few projects where we told users through Sberbank online stories about, for instance, how to prepare various interesting foods or meals at home, unusual meals, exotic cuisines, and what is worth noting, Sber never used to tackle the food business. We never had any information about what our users cook at their homes. And the case needed to be developed quite quickly, and so using the model, which was able to independently, without prior learning, to begin instantly processing the feedback flow and improve the offer rankings seemed the right choice. To launch the model, we needed to strongly develop our internal technological stack. So we had developed multiple solutions and upgraded the existing. We had gotten the storage for online attributes and flow processing for feedback and comments, and rather many other useful technologies. But classic model published at Yahoo was taken as baseline, called hybrid UCB bandits, hybrid linear UCB bandits that forecasted linear projections, but not through points, but through trust intervals. Hourly mini batches was the delivery standard. Now, this is the outcome. We did the A/B testing and tested the bandit model and few other baselines. The key baseline was random, and alternative was offline segments. We tried to segment the users into, for instance, offering Japanese food basket to those who used to visit Japanese restaurants in the past. And the bandits, in a little under a week, were able to find the signal and achieve positive outcomes. The case used limited traffic for testing. That's why ML stage took some time. However, we received at least 1.5 or twice as many, in most cases, positive feedback and comments from users, and the case was quite interesting. Another important conclusion, or the most important conclusion, is that the work on this type of cases is possible only if we do the ML learning with machine attributes online. And usually this is called feature store today. This feature store is the main challenge solved for the first case, because it needs to be able to work in completely different work modes, to combine packets like Hadoop and also updates from flow analyzers, and also be able to quickly respond to incoming queries from online running models. We have structured our own feature store model. We used the system of memory database and in-memory cache and persistent storage based on Cassandra. And accordingly, we integrated a lot into this type of gRPC. And our feature store ultimately provides for data export at high speed, writing at high speed, and also sub-millisecond delay on answers. The second case where the bandit was realized, this was Green Day office last year. Green Day was Sberbank's birthday, and for a birthday we give our users many presents and giveaways. Last year we rotated almost 150 offers at Sber and Sberbank crew. And here, these are non-personalized offers that people see pre-authorization at Sber. Now, as usual, in these cases, the offers are also finalized at the last moment. Apart from that, we are not aware of what they will contain, and models are necessary here that are able to also learn online. We didn't always used to know what type of users are we dealing with. That's why we used a combination of contextual and non-contextual linear bandits. And the users tried matching, and we tried user matching. We have collected over 500K plus clients, landings with bandits included, over 100,000. Also clicked our partners' offers. We saw a stable growth in CTR ratios based on our selection criteria. Next, we moved on to the main case, and this was Sberbank Online front page. This case was very important for the bank because it affects the financial bottom line, but this is a serious burden on the networks. Less than 100 milliseconds is the delay requirement on answers, which is quite serious, and also accessibility is an important consideration. We cannot allow the website to crash. We had used the same developed during the Green Day pattern. And so for Sberbank Online to present the offers to customers, we have structured the reserve point for delivering offers that was re-uploading in a classic offline format, and then clarified the query in online using our sysrec. Now, the case had already produced some interesting outcomes. We had launched A/B testing into 21% of traffic, and now working with necessary delays, and also we experienced a classic pitfall with the reward structure for our bandits. The point is that optimizing personalized offers through clicks is not a very good idea, because then we need to package a product, and the process may be quite extensive. And so for the bandit to provide quicker outcomes, we need to speed up the process. So this is the point of overcomplication, frankly, and that's why we received interesting outcomes in relative measurements. We were showing higher financial impact, but in total numbers, the bandits are losing, but we will continue developing the case.
So where are the main conclusions that we make now so far from the case of Sber? As it is the case with any other area mechanics, as we design the function of reward for the algorithm, the way it will be working, it is important that the business is involved into designing this function. What else to add to finalize? From experience of implementing bandits, they are really working effectively, and they allow us to improve the indicators of offline models, sometimes a little bit, but sometimes dramatically, quite dramatically. And through the development of technological environment for bandits, we open a way to implement online recommendations in the bank. Now it's not only bandits, but other models are launched in online mode and are working quite successfully. And the next steps, of course, we will continue developing this theme, and we will continue pilot with Sberbank Online and design proper reward function and experiment with new algorithms and methods of validation of such approaches. And of course, our team is actively developing. That's why we'll be happy if you join us. We are welcoming you, members of the team. That's it from me. Thank you very much for your attention. Dima, thank you very much. Very interesting. And there are a couple of questions. Unfortunately, I will be able to ask only one. A question is about prospects of bandits. Can you see future in them, or how do you perceive them? Will you have other algorithms in the future? You know, bandits is a very convenient formal thing. There are different bandits, and they work very effectively at the last stage. I mean, now it is the common practice that you make it 2 stages, generation of candidates and then ranking, but usually layer 3 is also quite useful. That ensures making the final decision. And on this stage, bandits work quite effectively, and in many cases they will stay and operate. But if we start developing a case down to the screws, so to speak, then there might be more complicated things, more complicated bandits on neural networks and approaches on the basis of RL methods spread in other areas. On the basis of policy gradient, there are very interesting works in Google on this. We are monitoring them, and we check, we try to adapt things for this. Another question to ask: what knowledge one should possess to get into your internship on your team? You know, you need to be enthusiastic, and you should be willing to work in this area, but also basic skills of programming and understanding of maths and ML experience. They are welcome, but this is not a blocker. If we're speaking about internship, we're always open and welcome new people. The requirements are not very high.